Recording 1080 still.
Right.
There's no less.
Is there not?
Unless NTSC is 720. I don't.
This is my notes here. I'm gonna put it as a transparency. We're gonna go through that as well. Yeah, and this is something to do with the structure. There is something extra I want to explain to you. Well, in here, as you can see here, structure is on the simply supported structure, yes? Which is the beam is just lying in top of the wall without getting clamped or anything. Sometimes the structure, one end is clamped and the other end is free. They call it cantilever structure. And sometimes the structure, one end is clamped, well, one end on the simply supported and another end on the roller is basically they put this sort of circle in there. It means it can move in the X direction, but it cannot go down, up and down. Does it make sense? So beware of that. And in terms of the reaction force or displacement, the table is there, and which you can match it. It's basically, as you can see here, for part A, building or fixed support. As we can see here, reacting force is a built-in or the fixed support here. There's going to be a X reaction in the X direction, reaction in the Y direction, and also a moment as well. Yes, and I put it as a tick. For the pin connection and the roller support is the same thing as well. Although you can see a displacement as well. We are not looking at the displacement right now. Just something is bending or changing the angle of the displacement. Yeah, we are not looking at that. Just we're looking at the reaction force in the X and Y and also the moment for this bending moment. And we are not looking at the pin structure either. Just to simply support it. Is there any question? Right. Very quickly, I'm going to go through these stuff, which is I'm showing to you. I gave you the handout. We're going to go together through that, read through it, yes, and it gives you some idea, and then we're going to do a questions. Happy? Is a shearing force and bending moment. I said the introduction, a structure member subjected to the transverse external force is called a beam, and these external forces cause a shearing force and the bending moment, which is come from the external forces. That's obvious. Moment at the cross section of the beam. The external force considered may be due to the concentrated or distributed loads. Yes, these external force either come from the concentrated or a distributed load. Beam mass and supporting reaction would be included as well. Yes, sometimes we take a beam as a light beam, which is has got no weight, and sometimes the beam, actual beam, has got a load as well. Does it make sense? We're talking about the beam, which is uniform shape everywhere. Wing of the aircraft is a cantilever structure, but it's not uniform. The tip is thinner than the root one, isn't it? It's a different shape. It's not exactly all of them as a rectangular shape. Shearing force. At any cross section of the beam, shearing force. At any cross section of the beam is the algebraic sum of all the external forces to one side of the section. So basically you have to balancing all the forces in the two different directions. Okay, look at the shearing force to the effect of the point C is, as you can see, a W minus R1 downward, and to the right of the point C is R2 upward. Therefore, there are of the same magnitude since W is equal R1 plus R2. Does it make sense? What did I do? As you can see here, that's a cutting point here. R1 is a reaction, R2 is another reaction, and that's the concentrated load in there. Am I right? Yes? And as you can see here, the result of this minus that one, it would be W minus R1. Am I right? One goes downstairs, coming force downward, the other one forcing upward. And the result of that, about the point C we're looking at, yes? As you can see here, the result of these R2 goes through this section of beam, which is, we call it the R2. That's a common sense, am I right? And ultimately, R1 and R2 holding in the positive X direction, Y direction, and W pushing downward, and they can balance it via condition of equilibrium. This is very simple and straightforward. Look at the way we're using, that was a shear force. Force, when you do the force, is only force, a direction of the force adding up or subtracting from each other. Okay? When we do the moment, that would be a different ball game. What's the moment is?
It's a force with rotation. Just phrase it in there.
Force and rotations. I'm not satisfied with your explanation.
No,
a moment. First, give me a definition of the moment.
It's
Moment is
a force around the point, so force times distance.
that's it.
Force
That's
is
called a
distance.
definition of the moment.
Force.
Yeah. And the unit of the moment, would it be?
Newton meters, yeah.
Obviously, Newton times meter, Newton meter. And therefore, the behavior of that either is going to be clockwise or anti-clockwise. Yes? There's another extra work here for you. A bending moment at any cross section of the beam is this is important, just memorize that, is the algebraic sum of the moments of all the external forces to one side of the sections. Okay? In order to calculate the bending moment, as you can see here, what I did is start with the point C here, and we do some calculation regarding to the moment. So, in order to do so, at any cross section of the beam is the algebraic sum of the moment of all the external force to one side of the section of the beam. As you can see here, we do the moment here, and you're taking the moment about a point, which is, as you can see here, the distance from here to the point C is A. So R1 times A, are you with me? And W times C. Where is this negative coming from?
It's opposing.
Opposing, yes, exactly. If I put my finger here and I'm looking at this point here, press it, it will go this way. Am I right? And it has another moment which goes the other way around. That's why opposing moment. And we have another one here which is for this force about this point as well. Right. Referring to figure above, the bending moment to the left of the point C is the R1A minus WC, clockwise, and to the right of the C is the R2 times B, which is anti-clockwise. These are the same magnitude since taking moment about the point A. Actually, we took the moment about the point A. Right. As you can see here, we've done the very simple maths here, and straight away we'll tell you how to do the calculation of the moment. It's very straightforward, and this is, as you can see here, very simple. Now, let's go to the next page, please. Moment is a force times the distance. Now be careful, one of them is bear it in mind, either clockwise or anti-clockwise. Therefore, the direction must become considered its directions. Yes? Right. Relationship between moment and the shear force. This part is a bit complicated, but you don't have to prove it to me. I'm going to prove this one to you, how these things come about, basically. Okay? Consider a small section of the heavy beam whose weight per unit length is W. If at the point P where AP is equal by X, we get a section of the beam, we take a cut at the point A, at the point P. Okay? And from beginning to the point of the cut, I call it the X. Are you happy with that? The shearing force and bending moment are S and M. As I told you, it's a point A here. I'm going to cut it at this point. Yes? There would be a shear force here, and there would be a moment at this point as well. And the distance from the point to the cut, I call it the X. At an adjacent point Q, where AQ is equal X plus little bit of X. Can you see that? Or delta X. I put here, okay, we're going to take another point, an adjacent point Q. Get another point which is called AQ, okay? Where AQ is X plus a little bit of extra. I was cutting at the X point. Now I'm going to go a little bit extra. I call it a delta X. Am I right? The shearing force and bending moment are. So that would be a change in the shear force. S plus delta S. Delta, it means extra shear or subtracting shear, yes? And M will change with a delta M as well. The change will occur because the distance is changing. Am I right? Providing which is there is no concentrated force act between P and Q. There is no external concentrated between P and Q. The force which act on the section PQ are as follows. Look at here. It does explain to you very nicely. Gentlemen, that was my point of cut. Yes? And it was a shear this way, shear that way. Am I right?
Yep.
And it would be a moment this way, a moment, another moment other way around when I'm collapsing. That was a cut at the point where did I cut it? At the point P. Now, give a little bit of extra. Little bit of extra. We move long side of the beam. That little bit of extra, what we call that? Delta X. This is a delta X. Although at the end, which is a cut, it was another moment and the shear force, when we're looking at that, and this is a concentrated load as well. Are you with me? The concentrated load, this bit has got a weight. Am I right? So every W is a weight per unit length. So W times the delta X is going to go downward. Am I right? Why? Because this is a concentrated beam. I'm sorry, distributed load. This is a distributed load. From here to there, there's a load. Beam has got a weight. And this is times the distance there. And when we do calculate the shear force at this end would be a shear force plus another extra shear force due to this distance, a change, which is a force is change as well, extra force is there. And also moment would be simultaneously will change as well. Can you see that from this point to that point, how much changed? The change in the shear force is a delta S. The change in the moment would be a delta M. Because why? Why did it happen? Because I changed the distance. I go across the beam. Does it make sense? How big is it delta? Depends how much you're going to choose. Yes? Is it clear? Right. Let's take a moment. Take a moment about a horizontal axis through the Q. Shall we? Let's take this axis Q and let's see how much moment and also forces are there. Take a moment basically, okay? About the point Q. You ready for that? When I take a moment about the point Q, what would it happen? At the point Q here, is there any moment?
Yes.
Yes. One of the moment is this one. Moment plus m plus little bit of m, which is change of the distance from there to here, which is I put here. Okay? This force S at here, about this point, does it create any moment?
Yes.
Can you look at that? Would you figure anything out of here? I will come back to that and explain to you. Just give it 2 minutes, just looking at it, see what you can figuring out of it. I will ask you questions. How you balance it, everything basically.
Delta x over 2 because we're assuming UDL to be working from the centre of the...
Absolutely. Right. What we're going to do here, I have this piece of beam. I'm going to take a moment about point M, about point Q. Okay? So in order to take a moment, it's a moment about point Q. That's the way we do the taking the moment. You start like this, it means you're telling me, I want to take a moment about point Q. So put your finger at the point Q. When I do the cutting at the point Q, is there any moment occurring?
Yes.
Yeah.
Okay, so we can say M is a moment, which is occur at that point, okay? You can take it positive or you can take it a negative, which is we have it here as well. Do you see that this M is already there? So if we adding all the moment and all the forces which creating the moment in there, you will see it as a such. This moment, you want to take it positive or negative in here?
Positive.
Sorry, we take it positive. No worries about that. Okay, which is in here I took it not negative basically. Okay, and I took this way positive basically. M plus D of the M I took it positive. Okay, so let's follow this rule. We take a M plus dm this way positive, which is the other way around, anti-clockwise. I took it positive. Okay, but it doesn't matter. Let's, for simplicity, we can go through that. So first thing, we can see at the point Q, there is a moment, M plus delta M, which is already there because of the cutting, yes? Plus, which is I took this one positive. This force, does it create a moment about the point Q?
Yes.
would be a force which is, oh, well, let's start with the beginning, shall we? This force here, S, does it create any moment about the point here?
Anti-clockwise.
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 Well, I took this one anti-clockwise, I took it positive. And I took it positive.
Positive.
Yeah, anti-clockwise. Usually you take it clockwise positive, but I do it anti-clockwise, it doesn't matter. As long as